Network defenses often start with a simple picture. Bad things try to come in, and your job is to stop them at the door. Firewalls, filters, and scanners all sit there watching the inbound traffic. But some of the most serious damage in modern incidents does not come from what enters the network. It comes from what quietly leaves. In this Tuesday Insights feature from Bare Metal Cyber Magazine, developed by Bare Metal Cyber, we are going to spend time on network egress controls and the story they tell about what is leaving your environment.
Think about all the ways data can flow out of your systems. Malware calling back to a command server, a user uploading files to an unsanctioned cloud storage site, a test system talking to random internet services because nobody restricted it. None of those activities look like a traditional attack hitting an exposed port, but every one of them can lead to data loss, compliance issues, or a deeper compromise. Network egress controls exist to shape that outbound traffic, spot the strange patterns, and turn the edge of your network into a place where decisions are made instead of a passive pipe.
At a basic level, network egress controls are the guardrails that decide which outbound connections your environment is willing to make and under what conditions. They answer questions such as which destinations are allowed, which ports and protocols are acceptable, and how outbound browsing or application traffic is handled. They are less about blocking the bad internet and more about defining what normal looks like when your users and systems reach out to the wider world. When they work well, they make it harder for attackers and accidents to move data out without being noticed.
It helps to see egress controls as a combination of technology and policy rather than as a single box or service. On the technology side, they often live in next-generation firewalls, secure web gateways, cloud security services, and sometimes in host-based agents that control traffic from individual machines. On the policy side, they are grounded in decisions about which partners you talk to, which cloud services are approved, which admin protocols are allowed out, and how all of that is logged. That mix means network egress controls sit both in your network and cloud architecture and in your governance and risk conversations.
It is also useful to be clear about what network egress controls are not. They are not just a legacy firewall rule that blocks everything except a couple of common ports and hopes for the best. They are not a replacement for identity, endpoint protection, or encryption. And they are not a magical solution that stops every insider threat or every clever attacker. Instead, they complement those other layers by limiting the paths data can take and by creating a trail of outbound behavior you can review, monitor, and investigate.
One way to visualize their place in your stack is to think in layers. Identity and access controls decide who can do what. Endpoint controls focus on the health and behavior of devices. Application security looks at how software handles the data it receives. Network egress controls sit at the point where all of that activity tries to leave your environment and reach external destinations. When teams see it this way, it becomes easier to have focused discussions about which safeguards truly belong at the egress layer and which should sit elsewhere. In most environments, network egress controls start with one design choice. Outbound traffic should pass through a small number of controlled choke points. Instead of every device talking directly to the internet, you steer outbound connections through edge firewalls, secure web gateways, or cloud-native controls around virtual networks. Those choke points become the places where you apply policy, perform inspection, and capture consistent logs. Without that consolidation, it is almost impossible to see patterns or enforce rules in a meaningful way. At those choke points, you define rules that describe what good looks like. That might include allow lists of approved domains or IP ranges, rules for which ports and protocols are allowed, and categories of websites that are blocked or warned on. You might also require the use of corporate DNS or web proxies, so outbound activity is easier to see and control. Every outbound connection is checked against those rules, allowed or denied, and almost always logged.
The quality and availability of those logs make a big difference when you try to understand what really happened during an incident.
A simple example pulls this together. Imagine a user's workstation becomes infected with malware that tries to contact a command server on an unusual domain using a non-standard port. The outbound firewall or gateway sees that the destination is not on any approved list and that the port is not permitted for that segment, so it blocks the connection and records the event. Those logs flow into your monitoring tools and line up with an alert from your endpoint agent on the same machine. An analyst reviews the combined evidence, confirms something is wrong, and starts a response. The network egress control did not solve the entire problem on its own, but it turned a silent attempt into a visible signal. All of this rests on several assumptions that can easily break if you do not pay attention. You need reasonably accurate knowledge of which applications talk to which destinations, and that means communication with development and operations teams. You need routing and DNS designed so that outbound traffic actually flows through your controlled paths rather than bypassing them. You also need enough skills and time to maintain those policies as your environment changes. If users can install their own VPNs, use personal hotspots, or deploy unmanaged cloud environments with direct internet access, then large parts of your outbound story may sit completely outside your control.
In daily work, teams use network egress controls to enforce quiet, predictable boundaries. A common pattern is to steer all user browsing through a secure web gateway that allows standard web traffic, blocks known malicious sites, and restricts high-risk categories such as unsanctioned file sharing or anonymization services. Most of the time, people simply browse the web and do their jobs. But when someone tries to upload sensitive data to a service that has not been approved, the upload is blocked, or at least logged and flagged, instead of disappearing into a service nobody is watching.
Another everyday use case is tightening outbound admin and infrastructure protocols. Many organizations allow outbound web traffic fairly broadly, but keep a very tight grip on outbound SSH, remote desktop, database ports, or other powerful protocols. Those ports might be blocked entirely from most systems or only allowed from very specific admin segments to a small set of destinations. That simple pattern can make it much harder for an attacker to pivot from an internal foothold to an external host using those channels, and it often provides a quick win when teams review and rationalize old outbound rules. Network egress controls also show up in more strategic design work for applications and APIs. An engineering team may deploy a service that only needs to talk to a particular database and a short list of third-party APIs. Instead of leaving outbound access wide open, they can define rules so that traffic from that service's subnet or security group is allowed only to those known endpoints. In cloud environments, this may involve using private endpoints, carefully scoped security groups, and service tags. Over time, organizations that adopt this style begin to treat outbound destinations as part of an application's design, rather than an afterthought that is fixed with emergency firewall changes.
There are also use cases that grow out of regulatory and data protection needs. Workloads that handle regulated data may be limited to a very small set of outbound partners and regional endpoints. Some organizations create dedicated egress paths for those workloads, with stricter logging and review, while more general traffic uses a separate path. This kind of design takes more effort and coordination, but it can greatly simplify conversations with auditors and regulators because you can clearly explain where sensitive data is allowed to go and how those routes are controlled.
When network egress controls are thoughtfully designed, they deliver several important benefits. They give you visibility into outbound behavior that would otherwise be scattered and opaque. They provide containment by making it harder for an attacker or a misconfigured system to send large amounts of data to uncontrolled destinations. And they create a structure where discussions about outbound access are anchored in actual patterns and risks, not just in broad fears or vendor promises. For many organizations, that clarity alone is a major step forward.
At the same time, there are real trade-offs. Building and maintaining good egress policies takes time and coordination. If you lock things down too quickly, you risk breaking legitimate applications, frustrating developers, and encouraging people to find workarounds. If you barely restrict anything, you end up in the familiar allow any outbound posture, where controls exist on paper but do very little in practice. Teams also have to deal with limits, such as encrypted traffic that hides deeper inspection, and cloud address ranges that make it difficult to express narrowly scoped rules without more advanced tooling.
The failure modes often look like a slow slide rather than a dramatic collapse. A team launches an egress project with strict policies, spends a few painful weeks handling broken applications, and then quietly opens things back up until the rules look almost as permissive as they did before. Or someone designs careful egress paths for on-premises systems, while cloud workloads simply use default routes straight to the internet. In those situations, network egress controls may still be present, but their impact is small because the routes that really matter bypass them.
Healthier use shows up in how predictable and explainable your outbound story becomes. If you can ask a system owner which external services their application talks to, and they can answer with confidence, that is a good sign. If changes to outbound patterns go through a basic review rather than showing up as emergency firewall requests, that is another. When monitoring tools surface unusual outbound behavior and analysts treat those alerts as meaningful rather than as noise, it suggests your rules and logging are tuned to the way your environment actually works.
You can also see positive signals in how other teams interact with network egress controls. Developers, cloud engineers, and operations staff bring outbound connectivity into design discussions instead of treating it as someone else's problem. Network and security teams work together to make sure that routing and DNS direct traffic through the right paths by default. When new tools or services are adopted, somebody asks what outbound access they require and how that access will be observed. Those quiet moments show that egress has become part of the shared mental model, not just a firewall configuration buried in a console.
At its heart, network egress control is about turning the edge of your environment into a deliberate decision point. It does not promise perfection, but it does give you a practical way to shape where systems and users can send data, to notice when those patterns change, and to limit the damage when something goes wrong. For working security and IT professionals, that means shifting outbound access from a forgotten default to a design choice you can explain, measure, and adjust over time.
As you think about your own environment, it may help to ask a simple question about a few key systems or segments. Who can talk to what, from where, and why? If that answer is vague or surprising, network egress controls are a useful lens for making it clearer. Over time, treating outbound traffic as something you design rather than something you tolerate can turn quiet risks into visible, manageable parts of your security story.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.